Okay. All right. So we are going to do a quick review. So last week we started meteorology. Can anybody tell me what meteorology is? What specifically? More. Okay, kind of. So what does the atmosphere deal with, or what? What's happening outside? It's raining. So rain deals with the what? The weather, right? So we're talking about when we get into meteorology, we are getting into the weather and forecasting the weather. Okay? So then the next thing we need to know is the difference between weather and climate. What's the difference between weather and climate? Anybody? Climate change. Okay. We'll talk about that. Are y'all doing anything in your off weekend here? I talked about this for 2 days. I know you had an extra long weekend. So weather is what happens day to day. And climate Okay, so over years, over time, okay? So weather is day to day, and climate is over several years, it's over time, okay? The next thing that takes us to is the atmosphere, and we're going to get into specific layers of the atmosphere, but the first thing we need to know is what the atmosphere is actually made up of. Does anybody know? Which ones? Which one did you say? Yes, oxygen. And one more. That's a little tiny piece. What's the other big one? Oxygen and nitrogen. Nice job. Okay, nitrogen takes up the biggest percentage, and then oxygen definitely less. And then there is a very small amount that has some other gases, argon being one. Okay. The next thing we need to know is talking about atmospheric pressure. So last week, I had talked about being on a plane. Has anybody ever been on a plane? Nope. Nobody's been on a plane? What happens when you go up in the air? You know? Yes, your ears pop, right? Okay. So as you go up, the pressure does what? Decreases. Okay, so think if you had a bunch of things on your head, like a bunch of styrofoam things on your head, right? As you go up, what's going to happen to those? Yep, they're going to decrease, right? So the air pressure decreases as you go up. The next thing that we talked about were the 4 layers of the atmosphere. What's the first one? The troposphere, okay? And that's where what happens? Weather. That's where the weather happens, okay? What's the next one? Yes, the stratosphere. Then the mesosphere, and that's the what layer? The coldest. And then last is the thermosphere, okay? And that's the hottest because it's closest to what? Okay, very good. All right. Then that took us through 1 day. Then we talked about 3 types of heat transfer. What are the 3 types of heat transfer? Conduction, convection, and radiation. You have to do a 2-1 on those, right? A discussion, okay? So what is conduction? Okay. No, convection. You said convection first, right? What's convection? Okay, so the currents. Okay, so an example of conduction would be what? Okay, yep. So it's direct, right? A radiator is another great example. So if you were to put something on the radiator and it was warm, what's going to happen to whatever you put on it? It's gonna also get warm because the heat is going to transfer. Then convection is the currents. So if you were to put a pot of water on the stove, right? The water at the bottom is gonna what? So the heat's gonna rise, right? So the bottom's gonna get warmer, hotter first, quicker, and then it will rise. And the last one is radiation, and radiation comes from the sun. So that deals with the electromagnetic waves. Okay. Also, talking about that, we have something way up there that protects us from that. What's it called? The ozone layer. Okay, the ozone layer. So the ozone layer helps protect us from those harmful UV rays. And then the last thing that we talked about last week for meteorology was the greenhouse effect. And what's the greenhouse effect? So you're thinking of the actual greenhouse. What's the greenhouse effect? No? Well, y'all are thinking of like an actual greenhouse. So does everybody know what a greenhouse is? Okay. What do you find in a greenhouse? Plants, right? Has anybody ever been into a greenhouse? What's it like in there? It's hot, right? It's super hot, right? So what happens when we're talking about the greenhouse effect, we're comparing what happens in an actual greenhouse to what's happening in the atmosphere, okay? So the greenhouse effect is what's actually happening in the atmosphere. So in a greenhouse, we get the UV rays from the sun, right? They come into the greenhouse, they get trapped, they bounce around, and that's what happens and inside the greenhouse, and that's why it gets hot, because the heat is trapped inside. Well, that same thing is happening in the atmosphere with greenhouse gases like carbon dioxide, methane. Okay, those are things that are bouncing around in our atmosphere, and then what happens to the atmosphere? It gets what? It gets warm, okay? So that's what the greenhouse effect is. So it's like what's happening in a greenhouse, but what's happening in the atmosphere. Okay, does that make sense? Okay, you're gonna see that again when you get to biology, so make sure you remember that. All right, so today we are going to talk about humidity and dew point. So water exists in the atmosphere as these three things: a gas, a solid, and a liquid. Okay, so the gas is water vapor, the solid is ice crystals, and the liquid are water droplets. Okay, so who can tell me what the difference is between a gas, a solid, and a liquid? pretty spread out. It's not quite like. Okay. So that's the difference between a gas, solid, liquid. Gas, a solid, pretty compacted tightly together, and a liquid, right, it has no definite shape, okay? Because it takes whatever shape that it's put in, right? Okay. My clicker is not working. So when we talk about solids, liquids, and gases, we can also talk about how they change state. So solid to a liquid is melting. So what are some things that we can melt? All right. Plastic. I was thinking butter. That's the first thing that comes to my mind, even though we're in their science class. Butter melts, right? Okay. All right. So when we're melting, an example we said was an ice cube. So ice absorbs heat and it turns to a liquid. Next, we can do liquid to a solid. That's freezing. Okay, so give me some examples. What's the first one that helps? Ice. Okay, so we take water and we turn it to ice. So water loses heat, and that's how we get ice. Okay. Next is a gas to a liquid. This is condensation. Where have you heard this word? What? The water cycle, that's right, along with evaporation. Okay, so in condensation, heat is released into its surroundings. So a great example of this, what do you see up there? A water bottle, right? Because what do they do? But what happens to the bottle? Yep, so it starts to sweat, right? So if you have this ice cold bottle of water and it's just sitting out there in room temperature or somewhere that's warm, you get water droplets on it, okay? It starts to sweat. So heat is released into its surroundings. Say what? Oh, that's a good one. This mine right here is wicked bad, right? Another one, if you walk outside, it's happening right now actually, because the rain brought in what? What's it like outside? It is wet because it rained, but what's it like? Huh? It's humid, right? It's muggy, yucky. I don't like it. That's why I'm ready for fall, right? All right, so another example, you walk outside, what might be on the car window? So water droplets, right? So the same thing is happening there, okay? But yes, it's like white. Okay? All right, at the bottom, we see liquid to a gas, and this is evaporation. So heat is absorbed from its surroundings. So evaporation means that what happens? Okay, it rises up. All right, next is sublimation, okay? This is when heat is actually absorbed. So this is a solid to a gas. And then at the bottom is a gas to a solid, and this is known as deposition. And this is when heat is actually released. All right, so humidity. That's what it's been like out there. And it's probably gonna be like that for a few days because we're getting what all week? Rain all week. Okay, so humidity, we've all heard of humidity, right? Living in North Carolina, yeah? So we all heard of humidity? Okay, so humidity is the amount of water vapor in the atmosphere. So air that has reached its water vapor capacity is said to be saturated. So think of something saturated. Wrong direction. Who does chores here? Do we do chores? Do y'all do chores in your house? No? Do you do chores? Do you do chores? I'm calling home on everybody. Yes, I'm calling home. All right. So, when you wash the dishes, what might you use to wash the dishes? A sponge. Okay. So what do you do if you put the sponge under the water? What happens though? It absorbs the water, right? Okay. But can it hold all of the water? So when it's full, it's what? Saturated, right? Okay. And then you got to do what to make it unsaturated? Squeeze it out, right? All right. So think of it like that. So it can't hold any more water. If something's saturated, it can't hold anything else. Okay, that's it. So humidity depends on temperature, since different temperatures have different saturation points. Excuse me. Hello. Hi. Nope. You're welcome. Bye-bye. All right. Is everybody following me? Perfect. All right. So next is relative humidity. So we talked about what humidity is. So relative humidity is the amount of water in the atmosphere compared to how much water the air can actually hold. Okay, so we're talking about relative humidity. So amount of water in the atmosphere compared to how much water the air can actually hold. So the air can only hold so much, and then it becomes what? Yes, but what's the word we just talked about? Becomes what? It can't hold anymore. Saturated, right? Okay. So this indicates how near the air is to saturation. Okay, so once it can't hold anymore, that means it's full, that means it's saturated. Okay? So actual moisture is the maximum moisture times 100, and that gives us our relative humidity. We're not going to get into that too crazy. All right, so hot air versus cold air. So the warmer the air, the more water vapor that it can hold. So by changing the temperature of the air, you can increase or decrease the relative humidity. So constant water vapor and higher temperature equals a lower relative humidity. Constant water vapor and lower temperature is going to give us a higher relative humidity. Okay? So what do you see up here? So what are these circles representing? What's it representing? Somebody tell me. What about it though? The maximum water vapor, okay? So what's the difference between these three bubbles? Okay, and the water vapor itself, did it change at all in those circles? What? No, only the outside outside circle is what is different, right? So this is our largest one, medium, smallest one, but the water vapor doesn't change, okay? So over here we have 20% relative humidity, but what's happening, this is at 5 p.m., but what happened at 5 a.m.? What happened to the relative humidity? It's the same size, okay? So it's 100% humidity, relative humidity, because this is fully what? Saturated, okay? Because it's reached saturation. Okay, so warm saturated air contains more water vapor than cold saturated air. So does everybody see what happened there? All right, next is specific humidity. So make sure we know the differences between these. So we're talking humidity, relative humidity. Now we're at specific humidity. Okay, so this is the number of grams of water vapor in 1 kilogram of air. So this is the actual amount of water vapor in the air. So on a hot summer day in North Carolina, you're looking about 20 grams per kilogram. And on a cold winter day, you're looking about 5. So that's a pretty big difference, right? So specific is the actual amount of water vapor in the air. Because when we're talking about something in specific, specific means what? Okay, so I might tell you, y'all eat fast food in here. Yes? Yeah? Tell me something. Give me a restaurant. Yours? Cookout. I like to know. Okay, cookout. So I tell you, go get me a milkshake. Right? What are you going to bring me back? A milkshake. Was I specific as to what I wanted? No, why? Because what didn't I tell you? The type of milkshake, right? The flavor that I wanted. I didn't tell you what I wanted. So if I told you that I wanted a chocolate peanut butter milkshake, was I specific enough? No. Okay. So specific humidity. Does that make sense? All right. So how do we measure humidity? That is correct. Okay. Did you know that, or you saw it on the board? Okay. All right. So we measure it using a hydrometer. Okay. So one type of hydrometer is called a psychrometer. So this is made of 2 thermometers. We all know what a thermometer is. What's a thermometer? Perfect. Okay. So we use what is called a dry thermometer and a wet thermometer. So a dry thermometer, that's dealing with the air temperature. And then wet thermometer, as water evaporates, it removes energy from the thermometer, lowering the actual temperature. Okay. So you would compare both of those thermometers in a table in order to find the relative humidity. So for example, in cloud, no evaporation because air is already saturated. So if it's saturated, it's what? It's cool. That's it. It's cool. So what do we use to measure humidity? Perfect. Okay, so this is a sling psychrometer. And then over here is a relative humidity table. So there's smaller differences between wet and dry. So that gives us a higher relative humidity. And then there's larger differences, gives us a lower relative humidity. Okay, any questions on that? Then there's what's known as a hair hydrometer. So this is an instrument that records the changing length of hairs when humidity changes. So human hair stretches when humidity increases. Anybody got the same thing I got going on? Nope. Sometimes. So did I wear my hair straight for y'all yet? Can you see my hair straight? Yeah. So my hair is naturally curly, right? And if I straighten it and I were to walk outside this morning, what do you think is going to happen to my hair? Yeah, it's gonna be like out here. Kind of like that. That's a lot of hair, huh? That's a lot of hair. All right. So one of the last things we're going to talk about is the heat index. Sorry, y'all. Hello? Yes. Oh, okay, for Candace. Okay, sweet. Thank you. All right, fine. All right, so the heat index, this determines what the air temperature actually feels like. So if you look on your phone and you were to pull up the weather, right? Have you ever seen this come up? Heat index. Yes? No? Maybe so? Huh? Not the graph, just heat index. Like if you were to see that on your phone. Okay? Or sometimes it says what it feels like. And when it says what it feels like, it's talking about the heat index. So high air temperature and low relative humidity, the air temperature is going to feel lower than what it actually is. But if there's a high air temperature and a high relative humidity, then the air temperature is going to feel higher than it actually is, which happens way more often in North Carolina than that top one, right? Y'all feel me? That's true, right? Living in this crazy state of North Carolina. All right. Does anybody have any questions? All right, last thing is dew point, okay? So dew point is the temperature to which air must be cooled in order to reach saturation. So if the temperature drops to the dew point, then the moisture in the air will begin to condense and form dew. So we see this a lot where? On the grass, right? Okay, so if the humidity is high, a small temperature will drop, which will reach dew point. And if the humidity is low, a large temperature drop will also reach that dew point, okay? So temperature to which air must be cooled to reach saturation. So if humidity is high, small temp drop. If humidity is low, we need a large temp drop in order to reach that dew point. That's what you see on the grass outside. So that happens a lot here in the morning, okay? I know my dogs will go outside and it wasn't raining and it's not raining and they come in and all their paws are wet.